Okay, continuing with section 2.2, MAC 1105. We are in problem number 9 of that lecture, and there's a bunch of questions here, all that you have to get versed in doing. So use the graph of F to determine each of the following. We're going to start with the domain. Please remember that the domain are the X values. So as you look at this, I know there's no arrow here, but this arm actually does flare out ever so slightly. And I want to emphasize that. So as far as you're going to scan this graph from left to right and talk about the X values that this incorporates. So it goes from negative infinity all the way up to and stops right at 2. So when you talk about all the X values that this covers from here to here, you're going to say negative infinity all the way up to and including 2. And that's why that colored in dot is there. When it talks about the range means the Y values. So basically you're going to say how high and how low it goes. So as far as how high this goes, this maxes out at a value of 3. And how far as how low it goes, now this was when I was showing you this right here, this was with respect to the X's, but this also continually goes down. It's flaring out wider and wider. So yes, the X's are approaching negative infinity, but so are the Y values. The Y values are also approaching negative infinity. So it goes as high as 3 and as low as negative infinity. You are required to mention the smaller number first when you give the interval. Okay, the zeros of F, in case you are not familiar with that word, that means where does the graph hit the x-axis? Okay, another way to describe zeros are the x-intercepts. And then we have to hope that you understand what intercept means. It means where does the graph touch the x-axis? That's what zeros are. So this touches the x-axis at -4. And it also touches it at 2. So the zeros are, now you're just mentioning 2 individual numbers. They're also called solutions. So one of them is -4, the other one is 2. And you can give it, because they are 2 distinct answers, we can give them in set notation. But when you are trying to describe a whole interval of numbers that the graph passes over, such as when you're talking about domain, range, increasing and decreasing, then it is interval notation. The intervals on which F is increasing. So this problem is like a review of everything you've done thus far. The only thing that hasn't been brought up yet is domain and range. Not that you haven't heard of it before, probably. But the increasing and the decreasing were the point of all the problems at the beginning. So intervals on which it's increasing. Don't forget, when you're doing any kind of question involving increasing or decreasing, you have to answer with respect to just the X values. So let's see. As I scan this graph from left to right, let's say that you were on a roller coaster, you'd be going up, up, up all the way until you get right here. And the X value associated with that, if I'm lining it up correctly, looks to be -1. Okay, so you got to get right to the tip top where the max is, where it stops increasing, and then follow it down to the x-axis, which appears to be -1, because that's -2, yeah, -1. Okay, so as far as the X values go, where this increasing journey begins, you're out here into negative infinity. And as you're riding that roller coaster, you keep increasing. Because the values out here, the X values that you're supposed to be talking about, out here have to be called negative infinity. So negative infinity all the way until we get to the x value called -1. Now, when you're talking about intervals of increasing and decreasing, they are open intervals. Please refer to the first 3 questions at the beginning of this section so that you can be reminded that these are open intervals when you're talking about increasing and decreasing intervals, because at -1, the behavior changes. And that's why you can't encapsulate it you can't encase it in a bracket. Okay, decreasing is where the graph is going down, 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 down. That begins, again, right at -1, where the behavior changes from being increasing to decreasing. So it begins at -1, and it actually dead stops at the x value called 2. This leg does not flare out into positive infinity as many of the graphs have thus far. So that decreasing interval starts at -1, but at -1, it's both increasing and decreasing. That's why you're not enclosing that in a bracket. But then right at the x value called 2, that point only has one behavior. It is part of a decreasing interval and only part of a decreasing interval. This number is part of both intervals, and that's why we talk about that with respect to an open interval. Okay, then going to the values for which y, that means y, f of x means y, values for which y is less than 0. If you don't know what they mean by less than 0, they're talking about the x-axis. So you want to find all the y values, the values for which the graph, now when they say the values right here, it's kind of hard for students to understand what they're asking for, because visually you're trying to look for where is the graph underneath the x-axis. The function itself being less than 0 means the portion of the graph that is below, that's what less than means, below the x-axis. When they talk about 0, below the x-axis. But then when you give the values, you have to give the answer in terms of x. And that's kind of what messes students up sometimes. They don't know whether they're, so I'm trying to really point that out to you. So you're looking for where the graph is below the x-axis. And that would be this portion right here. All of that is below the x-axis. So when you try to give the x values that are associated with that particular portion of the graph, well, you just want to talk about this end and this end. The x value right here is -4, whereas the x value for this tail end, remember this tail end keeps going on and on and on. So as far as what x value is this? -4. What x value does this tail represent? These are x's that go to -infinity. So where are the y values less than 0 for x values? From -infinity to -4. And again, I'm going to put that in parentheses because right at -4, that splits the behavior of this graph from the part of the graph that's above the x-axis to the part of the graph that's below the x-axis. It joins those two portions, and that point belongs to the portion above as well as the portion below. So it doesn't have a specific identity to either one of those sets. So that's why I'm using an open interval. Okay, any relative max or min. So this is the max right here at the top. So at -1, you have a max of 3. So I'm going to put 3 there as the actual relative max. I mean, it occurs at -1, And you'll have to believe that all they want there is just the y value, because they're actually they're asking for the actual relative maximum value. As far as the minimum value, what is the minimum value? It doesn't, let's see, the minimum value, nothing on this side, but now let's look over here. In this vicinity right here, the minimum value, because when you're asked for a minimum or a maximum value, you have to actually assign a number to it. So over here, there's nothing, because you can't talk about negative infinity, but a minimum value in this locality would be 0. So I am giving the y values for this. I gave the y value there because they're actually asking for the actual relative max or min, which I made a big point of when we were doing these problems on the previous page. So the y value there would be 0. So 3 for this answer, 0 for this answer. Okay, moving to part I. The values of x for which the y is equal to 3. Learn to read f of x as y. It has the meaning y. So you want to find the values. When they say the values, they're always talking about the x values that are associated with y equal to 3. So go to y is equal to 3 and then drop down to the x value that's associated with it, which is -1. So for this problem, -1, right there for I. Okay, is f of 0 positive or negative? This means, you got to learn how to read this. It usually says f of x. So if all of a sudden you see a 0 in there where the x was, that means they're telling you go to where x is equal to 0 and give the y partner. Okay, so going to x is equal to 0, you'd be right there. And then up to when you hit the y-axis, let's see what that looks like. I'm going to make this a little bit bigger and get rid of this so we can kind of concentrate on what's happening. All right, so if you go to x is equal to 0 and then up to where the graph hits, I'm going to say that that's it looks like to be approximately 2.5, where this graph cuts in. Again, I'm standing on x equal to 0, and I'm going until I hit the graph. It might be about 2.6. It could be 2.6, 2.7. Let's give it as approximately 2.7. Oops. I meant to put question mark there. So when x is 0 and you travel up to the graph until you hit it, the y is approximately 2.7 for that answer. They're telling you where to go here, and then you're matching it up with the y partner. So many questions, a review of the entire outline thus far. Okay, now we're going to go on to problem number 10. Sorry, this section's taking so long, but there's a lot of things here that you probably are not familiar with, because this is the section that jumps you into graph theory. And you don't get that in MAT 1033. You know how to do very few things as far as what I'm talking about right now. So this is where you formally jump into the MAC1105 concepts. Okay, in number 10, evaluate the piecewise function. That's easy. It's when you're graphing it that's possibly a little bit more challenging. But when you're evaluating, all you need to do is be able to successfully pick out which one of these functions to use. So maybe I can get part 1 done, and if I get cut off, I'll have to do it in the next video. So if you're plugging in -3, notice that this value is negative. And the way that we talk about negative values is that we call them numbers that are less than 0. So that means since you're plugging in a negative number, you're using that function. So when you go to plug it in, it would be 2 times x plus 5. This is the actual number you're plugging in. And then use your calculator if you need to, but that's -6 plus 5. So the answer there is -1, and you can write it as a point. You can put what you plugged in and the partner that you got as a result. Finishing up in the next video.